Hello, everyone. I'm Gilad Shainer and a board member of the UCF Consortium. And in the next 10 to 15 minutes, I will review with you some of the projects that the UCF Consortium is managing. The UCF Consortium mission is to create production-grade communication frameworks and open standards for high-performance computing, for deep learning and other data-centric applications. There are multiple projects that the UCF Consortium is managing. UCX is the first one, the Unified Communication X, which is an open source, lightweighted, high-performance point-to-point communication framework. There is also a project for UCX4 Sparks to bring the UCX capabilities for big data. Open Snappy, Open Smart Network API that create a standard API to be able to access compute engines on the network, such as Smart NICs or DPU, data processing units. UCC is a library that is similar to UCX from a performance criteria, but for collective communication, unified collective communication library. UCD for advanced data type engine and a benchmarking suite, HPCA, to be able to measure compute availability of data centers, taking into consideration that compute resources are not just coming from CPUs or GPUs, but they can also come from DPUs. We have a great board members coming from the industry, government labs, in academia, and we definitely greatly appreciate all the contributions that are coming from all the folks around the world that contribute for the software development and for the standardization efforts of UCF. UCX, which is the first project, started many years ago. The motivation with UCX was to actually combine multiple communication frameworks that existed at that time, either coming from the industry or coming from academia or government labs, and actually create a more unified approach, lightweighted, that support any network that you can think about, but actually have the options to go down into almost hardware level interfaces. And that communication framework, or UCX, as a combined, which is a combined, it's a combination, started as a combination of those previous frameworks, providing not just a unified version, but also much higher performance. So it was designed to be lightweighted, provide all the services needed, and supporting variety of networks. So why UCX? I think I covered that in the previous slide already. UCX first supports all the network that exist, and it supports all of the communication primitives that are needed for point-to-point that you need in MPI or SHMEM-PGAS, different kind of machine learning frameworks, data analytics, storage, and others. UCX enables pretty much direct access to network hardware interfaces. And then it supports all the CPU architectures or GPU architectures. So in a nutshell, you have a lightweighted framework that can connect to or be used for all of the compute and data intensive applications from one side, supporting variety of networks on the other side, and it's portable between multiple CPU and GPU architectures. UCX is probably becoming or has become the de facto interface for high performance computing. Most, if not all, MPIs leverage UCX or elements of UCX as part of their MPI, as well as being used for other frameworks, other high-level frameworks in the world of HPC and deep learning. Last year, in 2019, we were very proud to receive the R&D 100 award for UCX. It's a great testimony for the effort that a great team coming from the academia and industry and laboratories that put together and created a high performance, lightweighted, de facto standard for high performance and deep learning and database or big data applications out there. It was a great milestone, and of course we continue to add more capabilities to UCX, as well as putting a great effort in the other projects that I mentioned earlier. From a high level, UCX on one side provide interfaces for communication interfaces or communication frameworks, if it's MPI, Shmempigas, and so forth, to storage, to big data such as Spark, and other interfaces that are used for compute and data intensive applications. UCX is split it into three different components, and supports all the variety of RDMA, which runs over InfiniBand, for example, runs over Ethernet, supporting GPU and accelerators, and others, if those are proprietary networks, shared memory, and so forth. And again, UCX is widely adopted today in HPC, widely adopted in big data, widely adopted in deep learning. And it's always great to see more and more usage models of UCX, and how UCX enables actually people to increase their performance and capabilities from compute clusters. One of the, I think, important advantages of UCX is performance portability. It can run on Bluefield DPUs, it can run on NVIDIA Jetson, runs on ARM, if it's Thunder X, for example. Any device, actually any device, any architecture, if it's an x86 or an ARM or Power, and it's being used in world-leading high-performance computing and deep learning data centers around the world. Folks can use UCX to design their applications or develop their applications on any device, actually any device, and take that development that can do even in their home, and then run it on very large clusters or very large data centers. And we love testing. We definitely love testing. Testing helps us to make sure that UCX releases are very robust and they meet the performance criteria and the performance goals. We're running more than 100,000 tests per commit, and more than 220,000 CPU hours per release. We do welcome anyone that want to contribute any resources as part of the testing, and obviously the more testing we do, the better releases we can provide. We do have 3 releases a year. So we have done the 2 first releases already, and towards end of November this year, we're gonna have the third release this year. Again, there is a great effort from the community to provide test resources, and of course, anyone that would like to participate in the testing and help us with the testing, more than welcome to join our effort. UCX users are coming from many areas of the market, many areas of compute and data intensive applications. From an MPI perspective, virtually almost all MPIs are using UCX or parts of UCX. PGAS, leveraging UCX for GasNet. OpenSHMEM, leveraging UCX to provide a better performance and better scalability. Charm++, from CharmWorks, for example, can run natively on UCX. And by running natively on UCX, it can provide better performance and better scalability for applications that are utilizing or using Charm++. Rapids, Dask, Nickel, example for deep learning libraries that are running over UCX in order to leverage the performance and capabilities of UCX. Here is a slide that has useful links for UCX or UCF. You're more than welcome to join the mailing list. You're more than welcome to check the UCX website, openucx.com, where you can find information about the project, information about the release, where to find the code, as well as if you'd like to join the development team, where to find the contributor agreement, and as well as information on our 2020 developer meeting, which this year will be a virtual one. And I do hope that in 2021 we'll resume back the physical developer meetings. In any case, the 2020 virtual developer meeting is going to happen at the end of November, beginning of December. It's going to last for 4 days. Right now we look on 4 days, and will include a lot of topics of UCX development, as well as usage models, and some other great talks from other area from other areas that the community is interested in. You can check the agenda, and you can see the list of topics there. And I do encourage you to join us and learn more on UCX and how you can leverage UCX. So a little bit on the other project of UCF, Unified Collective Communications, or UCC, is putting a similar effort that we did for developing UCX, but for collective communications. So the combination of UCX and UCC will cover the entire range of point-to-point and collectives, and will bring the scalability and the performance and the advantages of UCX for collectives with UCC. OpenSnappy, Open Smart Network API. It's an effort to create a standard API to access smart NICs and DPUs, and to be able to get the resources of the DPUs or the smart NICs to the applications in an easier way. UCX for Apache Spark. It's a project that brings UCX to create a plugin for UCX to Apache Spark. HPCA, it's an effort to create a benchmarking to measure the performance availability of a data center. The performance or the compute availability that the data center provides, it's not just coming from a CPU or GPU. It's also coming from the network, or it's also coming from DPUs, for example. And the mission of HPCA is to create a benchmark suite that enables us to measure how much actual compute availability we have in our data center. UCD, it's an engine that is development for serialization or deserialization. and UCX Pi, it's a Python binding for UCX. So as you see, there is a lot of great projects that UCF is managing beside of just UCX. You're more than welcome to check the UCF Consortium website and get more information about the consortium itself and on the different projects. We do welcome more entities to join UCF in different kinds of levels. And definitely the more entities that will join us will be able to bring much greater value to the community. Any questions, by the way, about UCF Consortium? Easy to get answers. Just email info@ucfconsortium.org, and we'll be very happy to get back to you. So with that, I'd like to thank you for listening. Again, UCF, it's a great collaboration of industry and labs and academia with the mission to provide standard APIs and frameworks for computer and data intensive applications that one can use on any platform, to run on any network and on any device. If it's a small single device that you can program, and up to the largest data center or largest cluster you can think about. Thank you very much for listening.